Hey guys, welcome aboard to the video. Today we're going to be taking a look at a topic called binary search. This is a video that has been requested by one of my friends. So today we'll take a look at what binary search is and how to implement it. So binary search is just one of the ways of searching in programming. It's a pretty popular topic, especially if you're doing computer science. It's just one of the ways of doing searching. There's so many other algorithms that handle this specific thing. So we'll take a look at the conceptual overview and then we'll implement it in code. Okay, so right here I've got a random list of numbers, but one thing to note about it is that all of these numbers are in ascending order. Okay, so we've got 1, 8, 10, and then it just keeps on growing till the number 65. That's one thing to note about binary search, is that it only works with a list that is sorted, whether that's alphabetically, descending order, ascending order. Your values, they just have to have some kind of order in order for you to be able to use binary search. Okay, so let's take the example of us looking for the number 60 in this list that we have here. Now, the normal way that people would do it is they would just go through each of the numbers and kind of like in a for loop and try and see, hey, is this 1, is it equal to 60, and so on and so forth for each of the numbers till they get to the number 60, and then they basically return that. So that's what's called linear search, because we basically start from the start and then look at each of the values in a linear manner up to when we get to the value that we're looking for. Now, the problem with this is that when our list is pretty large, it can get slow. It can tend to get slow sometimes. And we'll take a look at the difference between linear search and binary search in terms of time complexity and space complexity. But in this case, we have so many items, and if we're looking for the number 50, and we know that our list is sorted, it doesn't really make sense to look at all of these values. There's a better way to do this, and that's where binary search comes in. Yeah, I've just got this emoji here to show that it's pretty frustrating to go from all these values to just get the number 50. But yeah, so let's go back to our initial example. We're looking for the number 60, yeah? And the way that binary search works is that, first of all, what we do is we identify a midpoint in our list. Okay, so right off the bat, we just look for the middle point. In this case, the midpoint is the number 37, which is what we've got here, and we compare the elements that we're looking for, which is the number 60, with that midpoint. Okay, and if that midpoint is if the number 60 is either greater or less than that midpoint, then we do something. If it's greater than that midpoint, then we know that everything before the midpoint is pretty much useless, so we don't need to look at any of the values there. Going back to this example right here, instead of going through each of the values one by one, we identify the midpoint somewhere like here, and we know that this midpoint, the number 50, is greater than that midpoint. Then everything before that is pretty much useless, so we don't have to take a look at it. Okay, so we repeat this step a couple of times until we get to the value that we're looking for. So in this case, the first step, we've eliminated everything that's before the number 37, and we've identified a new middle point in our next list, which is starting from the number 40 all the way to the number 65. And we keep on just doing these steps until we finally get our number, the number that we're looking for. Now this is good because, as you can see, we've only gone through 3 steps. This midpoint, this second midpoint, and then in this third midpoint, we found the value that we're looking for, as opposed to going through 9 steps to get to the number 60, which is initially what we did with linear search. So that's pretty much how binary search works, is that we're just going to do this step a couple of times where we identify the midpoint and we compare it to what we're looking for until we get to the number, or if the number is not really there, then we just know how to handle that kind of a scenario. Okay, so let's jump into how it's done in code. Okay, so I'm going to be implementing this in JavaScript. So I've got a function here called binary search. It takes in two different parameters. Now the first one is a list that we're actually going to be looking for the value in, and then the second parameter is the actual value that we're looking for. So down here I've got a couple of examples. This list that we have here, we're looking for the number 20 in that list. And what it should return is the index of that specific number that we're looking for. So in this case, it would be 0. So what we're expecting is 0 because the index of 20 in this list of numbers is the index 0. If you're not familiar with the way that arrays work in JavaScript or the way that lists work in just different programming languages, is that each of the elements inside a list is indexed by a certain number. So we usually start from the number 0 all the way to like the length of what we have there. So in our second example, we're looking for the number 89, and in this list the number 89 has an index of 4. Okay, 0, 1, 2, 3, 4. And then in the third example, we're looking for the number 105. It's not in the list, so the way that we should handle that is we should just return -1, which is just short for we didn't find what we're looking for. Okay, so I've got a couple of steps right here. The first thing that we're going to do is we're going to create pointers in the list for the start and the end. As you saw, it's pretty important that we know what the start and the end is because we're going to be updating that based on like what we're doing. And then right at the start, we're going to calculate the midpoint. So the current midpoint of the entire list, which is this right here. And then while we're going to do a certain action while we have not found the value that we're looking for. So remember when we were repeatedly looking for the midpoint and then shortening out our list. So that's what we're going to do in the form of a while loop. So we're going to say while we have not found the value that we're looking for, we'll check if the value is greater than the midpoint, and then we'll adjust the start to be the middle plus 1. Now what that means is just that if this 60 is greater than this 37, then disregard everything that's here and make the start be after the midpoint, in this case the number 40. Okay, so in the case that the value is less than the midpoint, then we're going to do the opposite. So assuming that we're looking for the number 10, for example, this end is what we'd adjust to be this 25 because we don't mind about everything that's after the number 25 or after the number 37. So that's what we're going to be doing there. And then there's one little step that I forgot to put in there, which is that after we've done that, in this case, we have to recalculate the midpoint because it's no longer 37, it's a different number. So I'll just put in that comment right there, recalculate the midpoint. And then last of all, we're just going to return the index of the value in the list if we found it. So remember, if we found the value that we're looking for, we're just going to return, that index, which would be the middle, which is basically what we're defining as the middle or the midpoint. Okay, so let's jump into it. So the first thing that we're going to do, create the start and the end. I'm just going to do that in a variable. So I'll just declare the start and the end. And actually, I'm just going to put them in separate lines so that we can actually do this. So the start is going to be equal to the index of 0. We're starting at the start of the list, which is 20, so that's going to be the index of 0. And then the end is going to be basically the length of this list minus 1. Minus 1 because the list starts at 0 and not at 1. So the way that we do that is we say that array and then the length of the array, the way that you do it in JavaScript, you just do array.length, and then we're going to do -1 to get this end right here. Okay, and then make sure that that's a semicolon. The next thing that we need to do is to calculate the initial midpoint. So we'll say the middle is equals to, and the way that we're going to calculate it is we're just going to take the end and then the start, we're going to sum those up, and then we're going to divide that by 2. It's going to give us the midpoint. Okay, so the way that we do that is just we do the start plus the end, and then we're going to divide this by 2, and then I have to do this parenthesis so that it starts with the addition, then it goes to the division. Bodmas. Classic. But yeah, but there's one thing to note with this is that if we continue to recalculate, there might be a scenario where we get like a floating point. In that case, what I mean is something like an index of 2.5. Now this is invalid because we don't have an index of 2.5. Index are like whole numbers, not floating numbers like this. So in order for us to guarantee that we're going to get a whole number, we're going to do something called math.flow. Okay, and then that's basically just going to guarantee that we have a whole number. Okay, cool. So the next thing that we're going to do is now we're going to redo this step that we've done right here. We calculate the midpoint, compare it, we see if it's the value that we're looking for. If not, we're going to do a couple of steps. Okay, so the way that I'm going to do that, I'm going to say while, and then I'm just going to basically say array at middle. So what we're doing is we're checking for the value. So for example, in this case, 50 is the middle, and we're looking for the value of 50. And we compare it to the number 20, which is what we've provided as the value. So we'll say if it's not equal to the value that we're looking for, then we're going to do a couple of things. Okay, and I'm just going to copy and paste this comments up here. If the value is greater than the midpoint, then we're going to adjust the start to be the middle plus 1. So that's basically moving the start all the way to here, because we're disregarding everything here if we're looking for the number 60. So the way that we do that is just we say if the array at middle, so we'll say if the value is greater. So if the value is greater, this is how we represent greater, is greater than the midpoint, then what we're going to do is we're going to say the start is equals to, the middle plus 1. Okay, simple as that. That's how we move this start all the way to the number 40 in this case. But however, remember the second case. If we're looking for the number 10, then basically this 37, this 65 will basically move to 25 right here, because we're looking for everything now that's on this half. So the way that we do that is we'll say that, okay, else what we're going to do is we're going to say the end is equals to the middle minus 1. Okay, so that brings the end to 25, which is middle minus 1. Okay, so let me copy and paste this up here. And then if the next thing that we're supposed to do after we have recalculated the start and the endpoints, we've adjusted them, now we need to recalculate the midpoint. Okay, and this is pretty much what we did here, so we can just copy and paste that line, just this line without the let, because we're not redeclaring the variable, so we just reassign the middle to be now the start and the end, which would be the new start and the new end. I hope that's not confusing. Okay, and that's pretty much our while loop. And then if we don't run into this case, assuming that we've recalculated the middle and we found out that, hey, the middle is actually what we're looking for, it's a value 60. Well, in that case, what we're going to do is we're just going to return the middle, which will be the index of the midpoint. Okay, in this case it would be 0 if we're looking for 20, because 20 is right here. Okay, so let's take a look at if this is going to work. I'm just going to hit Command I on my keyboard, and hopefully I can adjust this. Now what I'm going to do is, because you can't see it here, what I'm going to do is I'm just going to console.log before I actually return a value. So I'm going to console.log, and then I'm going to say this is our answer. Okay, cool. So this is our answer. Now let's see if this works. Yeah, cool. So it says this is the answer, and then it brings us the middle, which is 0, which is basically what we're looking for. Okay, so I'm going to uncomment this, and then I'm going to uncomment this, and then comment this first one, and then do the same thing. And in this case, we see that we get 4, which is basically what we're looking for. The answer is 4. Now, there's one little caveat that we haven't looked at, which is in this case where we don't identify the number that we're looking for in the list. Now, in order for us to handle this case, because if I run this code, we won't actually get an answer. We'll just get a recurring loop, which is what we've done here. So we need to make some adjustments in this while loop right here. Now, if we continue to just do this and we don't ever get the value that we're looking for, we'll just continue to reassign the start and the end, which is not exactly the behavior that we want. And so I'm going to add this little phrase right here. So we're going to say, while we have not found the value that we're looking for, and the start is less than equal to the end. So basically we'll continue to reassign the start, but if the start is basically after the end, it just means that we've reached the end of the list, if that makes sense. So in this case, we're looking for the number 105. We've identified 50 as a midpoint. Okay, so we move start to 89. 105 is still greater than 90, which would be our second midpoint. So we say that the start is now equals to 90 and 95. The midpoint is 90. It's still 105 is still greater, so we move the start to 95. Now the start is equals to the end, still greater, so the start will now be something that is undefined, which will be basically something that's outside the list. In order for us to handle that, we just say while the start is also is less than or equal to the end. If this case is not met, it means that we're outside the loop. Okay, so one other thing that we need to do right here is we're going to say that if the array in the middle is not equal to the value that we're looking for, then what we're going to do is we're going to return this right here, which is -1. Okay, so I'm going to say return -1, and then we won't get to this point right here because we would have already returned this value. Now I'm just going to console.log this and also add it up here, and then I am just going to say that I'm going to console.log -1 because we did not find a value. Okay, now if I run this last part right here, we should now get -1. So I'm going to save that, and then I'm going to run that, and then voila, you see we've got -1, because basically 105 does not exist in the list that we have here. Okay, so let's say that maybe you're looking for the number 50. What's that look like? So 50, save that, and then run that again. You see the answer is 3. 0, 1, 2, 3. 3 is the index of 50. Let's try with the final example, the number 23 that we have here. Save that, run that. Okay, 1. So our binary search works, and that's basically how to implement it. Okay, so let's take a look at how these two algorithms perform. I've got linear search and then I've got binary search right here. So linear search is what we saw initially in the conceptual overview. That has a time of O of n, and binary search is what we just implemented. It's got a time of O of log n. Okay, so I'm going to try and explain this as simply as I can. Now for linear search, O of n, so what does this mean? Now basically n is the number of items that we have in the list. In this case, we've got 7 items in the list. And in the worst case scenario, say we're looking for the number 95, we'd have to go through this list 7 times in order to get the number 95, because we're going through it linearly, as you can tell from our initial conceptual overview. So basically, our time grows depending on the input that we provide into our function, which is this binary search, our algorithm. So if we have 100 items and we're looking for the last item in the list, then it would take 100 times to get to that last item. So that's what O of n means. Now in this case, binary search has a time of O of log of n. Now I'm not really good at explaining how logarithms work, but you can look for a video online. But this is basically log to the base of 2 of n. If you know what like 2 to the power of 2 is, or 2 to the power of 4, it's basically the opposite of that. But here we just assume that we have a base of 2. That's just basically how we simplify log n. So log n, it's kind of like saying that it takes half the amount of time. But okay, I don't want to say it takes half the amount of time, because that's false. But it basically takes less time than it does for n, as you saw in our initial conceptual overview. So let me just actually show it with this example. The midpoint, we only calculated it, what was it, 3 times, and we basically got close to the end. So if we're looking for 65, we'd basically go for a total of 4 times. Yeah. However, for linear search, as you saw, to get to 65, we'd have to go 10 times, which is basically from the start all the way to the end. And as our list grows, then that kind of factors in, as seen in this huge list that we have here. So I hope that kind of makes sense. For now, the best that I can do is just to say that binary search is faster than linear search. But always remember that binary search works with a sorted list of data. If our data is not sorted, then we just have to settle for linear search. Okay, so I hope that you guys enjoyed this video. Give it a thumbs up if you found it informative, and I'll see you next time.